Greetings. This is a second video to talk more about productivity, FTES, FTEF, weekly student contact hours, and where these numbers come from and how they're developed. It's more of a nitty-gritty, down to the details level explanation. What's all this about productivity? What we have on the screen is 11 easy steps on understanding and calculating productivity ratios in a community college. Just joking. So let's kind of scale things up here a little bit, make it a little easier to see. So, the first thing we're going to start with is Einstein, because he's got this memorable quote, whether he said it or not, still in question, but things should be made as simple as possible, but not any simpler. And I think he's onto something there. That said, it doesn't take a genius to figure out FTES and faculty productivity in community colleges. So the purpose of this video is to actually introduce these concepts to people who may not have faced them before. So the first thing we're going to look at is this box here. Why is FTES 525? Why is this 525 a magic number? Alright, so here we go, walking down through it. If you have one student who enrolls in 15 hours of class per week, and that traditional term is 17.5 weeks long, and then there are 2 terms per year. Well, if we take these values and multiply them together, 1 times 15 times 17.5 times 2, you come up with 525. Well, not too many students, in a sense, enroll in 15 hours of class, just exactly 15. Some do more, some do less. A lot of adjunct or part-time students come in and they'll do 4 or 5 hours a week maybe. And so the state pays for the equivalent of 525 hours across any number of students, any number of classes, hence the E, the equivalent part in full-time equivalent students. Okay, so let's scroll over here to this pink box. So how do we earn FTES in our classes? Alright, pretty simple, just multiplying some things together. You start off with the enrollment, so maybe you got 30 students enrolled, and then you multiply that by the contact hours per week. So again, we're a traditional semester here example. 3 hours a week, it's 3 50-minute sessions, or it's 2 75-minute sessions. We're going to multiply that by the number of weeks in the semester, which is 17.5, and you go 30 times 3 times 17.5, and it gives you 1,575 total student contact hours. And then you divide that by 525, and you come up with 3 total FTES. But wait, you say, our semester is not 17.5 weeks long, and that's true. Our semester is actually 16.4 weeks long, and our contact hours per week isn't really 3.0 either. It goes up to about 3.4, and this is assuming that we're doing 2 85-minute class sessions per week, which are 1.7 hours each. So if we take enrollment times 3.4 hours each times 16.4, you get 1,672 contact hours. Divide that by 525 and you get 3.19 FTES for that class. Okay, so as you can see, the traditional 30 student class has gone from having 3 FTES in a traditional semester to 3.19 FTES, not quite 10%, and that growth is attributed primarily to the compressed calendar. Okay, moving on. So then the person says to themselves, well, why in the world do we care so much about these FTEs? Why is that such an important measure for colleges? Well, and truthfully, FTES is how we are paid. So all income, all general fund income to the college comes via FTES. And so the state pays each district a certain amount of income per FTES. At the current time, that's $4,565 per FTES. So you multiply that by the FTES earned within that class, so that's 3. And if we're looking right over here, that's 3 FTES over here. So the total income for the district is $13,695. But then we have to take out the instructor pay. Now this is a huge variable. This is a very simple example. We're just assuming that it's a $70,000 annual salary, and the class is a 20% class, and that comes up with the instructor being paid $7,000 as salary for that class. But if you had someone with a lower annual salary, then that number would go way down. If you had adjunct faculty, that would go down quite a bit. Some of our more seasoned faculty earn almost $100,000 a year, so this number goes up quite a bit. Nevertheless, when you take out the amount that the instructor is paid, the $6,695 is the amount of money that's left over for other use within the district. For any other use, that could be the benefits that are associated with the instructor pay. It could be the administration for the department, the administrative support, it's the payroll department at district, it's groundskeeping, it's custodial, it's college administration, district administration, it's folks in various support offices throughout the campus. But this is the amount left over from this 3-unit class that goes to those other purposes. So looking over at the calendar issues, how does this compressed calendar that we work in affect our income? Well, as we talked about over on the left, here we've got 3 FTES in a traditional semester, and the same class gets 3.19 FTES in the compressed semester. If we now come over here and take the same income per FTES and multiply by 3.19, it grows to $14,500, which is about $900 more than what was above. And if you take out the same $7,000 instructor pay as before, because there's no salary bonus in the compressed calendar, then there's more money. There's $600-700 or so left over for that's almost $900 left over for other uses in the district. Okay. All right. So FTES matters so much because that's our funding source. Let's move down. Alright, so how do you calculate these WSCH or the FTES per FTEF? Well, this is actually very, very simple. In the example above, the class generated 3 FTES. And you just divide that by the total load associated with that class. So that class was a 3-hour-a-week class. It's your traditional 20% lecture class. And so 3 divided by 20% gives you 15. So the FTES per FTEF for that class is 15. Now, let's kind of extend that a little bit. Let's assume that that same teacher, earning whatever they earn per year, but they're just the cookie-cutter classes. They do 5 3-unit lecture classes during the semester. Each class has 20% load, and each class has 30 students on census day. So these classes are all identical. Well, since they're all identical, we just take the one class and multiply by 5, and that's 15. 3 FTES times 5 makes 15. We take the total load, which is 20% times 5, and that makes 100% load, and divide those things. And so the FTES per FTEF for the entire semester for that person is 15. Okay, now, does the FTES per FTEF change in compressed courses? And the answer is yes, and does for the same reason as above. Over on this side, we're increase the FTES. So that class is now earning 3.19. You divide that by 20%, and that gets you this 15.93. Okay, so the productivity ratio, FTES per FTEF, has gone from 15 to 15.93 because, and this is just in one class, because of the compressed calendar. But if we use that same example, this extended example, with 5 3-unit classes exactly the same, 30 students each, then 15.93 is the same. It's averaged out over all 5 classes. So what does this FTES per FTEF indicate? Here's one understanding. This is the one that works best for me. As you look at a traditional term, if you have an FTES per FTEF ratio, which is 15, we got to think about how this FTEF stands for the full-time equivalent faculty, which was adding up total loads until you get to 100%, and that was within a semester. So each faculty member, full-time faculty member, gets to 1 FTEF in a year, or in a semester. And so if they do 1 FTEF in the spring and 1 FTEF in the fall, that's 2 FTEFs per year. So if we just take the 15 multiplied by 2, then this 30 gets us to the FTES per year for that faculty member. So the net result of the total full-time equivalent students taught by that person per year. Now if you think back to the example, if this faculty member teaches 5 3-unit lecture classes a year, or a semester, and each one has 30 students in it, and they do that in the fall and the spring, and there's 30 students in each one of them, and this is a FTES per year coming out at 30. You see where I'm going with this, right? The 30, this taking the FTES per FTF times 2, giving 30, gives you this nice measure of the class size. In fact, this 30 is exactly equal to the class size. And where that's important is down below, because most of the time people don't teach 5 classes that are identical with the same number of students and the same 20% load. And in the compressed calendar it gets especially tricky. But in the calendar here, if we take a 15.93, almost 16 FTES per FTEF, and double that, then that gives you 31 and almost 32. So in essence, this faculty member has an effective class size of about 32 on average over the course of the year. So how do you calculate WSCH per FTEF? In a traditional semester, let's look at these numbers here only, okay? So in a traditional semester, you take your enrollment, which is 30, and you multiply by the 3 hours per week, and that tells you that you have 90 weekly student contact hours. Okay, this goes back to that traditional semester, 18 weeks long, but they call it 17 and a half, and in each week there's 90 of those weekly student contact hours. Now, generally you take those numbers and multiply out times the number of weeks and then calculate the FTES based on those. But in this ratio, we just leave it back at the week level. So if we take the 90 weekly student contact hours and divide that by 20%, which is the load for the class, you come up with 450 as the weekly student contact hours per FTEF. And that number is lower than what people are looking for. Look at this box here. In California community colleges, WSCH per FTEF ratios are desired to be in the 500s and above. College-wide, that should be the case. You know, vocational programs are going to be less than 500 because they have smaller class sizes. And then the cookie-cutter lecture classes in social sciences are often in 700s, 800s, or even higher. So this 30-person class has a WSCH per FTEF of 450. Now if we take the same 3-unit class and we increase the enrollment from 30 to 40 students, then that gets a WSCH ratio of 600. And if the average is 50 students, or if that class has 50 students in it, then the WSCH value goes up to 750. So as you can see, these enrollment numbers significantly affect the WSCH per FTEF. Does this stuff change in compressed courses? Do the weekly student contact hours per FTEF change in compressed semesters? Well, yes, they do in actually an incorrect way. Check this out. If you take your enrollment of 30 students and you multiply that by 3.4 contact hours per week, so in a compressed calendar, we need to use this weighted WSCH value. So what we're going to do is we're going to, again, let's concentrate on this first column. So we're going to take an enrollment of 30 students with a little asterisk. So we're going to come down here. This is assuming that the course is... I hope this has proven effective, and I hope it helps you to fill out the trend analysis boxes over here to analyze these ratios a little bit, and then to provide whatever information you'd like to here in this analysis box.